Okay, this section talks about data distribution and it's kind of relates probability with data. Now, look at this distribution. Relative frequency distribution of lifetime of 800 electric devices. Now, the center of the data is usually called the mean. Is the mean, and you know how to calculate the mean. Now, you are going to learn something very advanced. It might not be this video, it might be the next video, but this video and the next video is very much related. For example, so when you move away a bit like this to the right by one standard deviation, so you have one standard deviation, that's the D. If you move again the same distance, you're going to have two standard deviation, and like that to the left. You move away, it means that you are moving away by one standard deviation to the left. The reason why this one is negative because of just the direction. There's no big deal to it. Now I'm going to explain this in details to you later. I'm just showing you on how to use this to solve question. So now if you read this, probably you get to understand better. This other one is talking about random variable, and let's do this question. Now, in the data from example 4.11, if you check back, you see that consisting of numbers of children, let X represent the number of children in a randomly chosen family among the 25 families. What is the probability that X is equals to 3? That's 1. That X is more than 3? That's 2. That X is less than the mean of the distribution. So those are the three questions. So the probability, this is the data. They showed up for convenience. But if you check back, you see the question by itself. But you don't really. It's what I've treated it in one of the previous videos. But this is data for us to apply so that we won't waste time. So this is the number of children. 0 or 0 children. They have 3 frequency. They have 3 people family that has. This is the number of family. Like they have 25 families, right? So those that do not have any children, there are 3 families. Those that have 1 children is 5 family. Those that has 2 children, there are 7 families. Those that has 3 children are 6 families. Those that has 4 children are 3 families, and those that have 5 children is just 1. Now the question is asking, what is the probability that X is 3? X here is representing what? Okay, they said X represents the number of children in a randomly chosen family. Now, if X is equal to 3, this is X. If X is 3, so what's the probability? So they said what's the probability when X is 3? So that means 6 over 25, because this, I told you about probability. This is the number of family it has, so that will be 6 here, because 3 is representing 6 here, over the total number, which is 25. That's 6 over 25, and that's the answer. Let me show you here. Since the family with 3 children each of, okay, since there are 6 families with 3 children and each of the 25 families is equally likely to be chosen, the probability that the family will be 3 children will be chosen, that 3 children will be chosen rather, is 6 over 25, like I just told you, 6 over 25. Now to do this next one, now this is the second one, that X is more than 3. Now that X is more than 3, let's look at the data. This is 3, right? For X to be more than 3, this one is not correct, so it's 4 and 5 that is more than 3, right? That's when X is more than 3. So that's what's the probability for 4? That's 3. What's the probability for 5? That's 1. So if you add it together, that will be 4 over 25. So just the same logic. Or if you want to do it individually, that can be 3 over 25 plus 1 over 25 is still going to be 4 over 25 when you add them together. So if you add, for me, this is a shortcut for me. Just add these two numbers together, 3 plus 1, that's 4 over 25. So see the same thing, or you can do it separately. 3 over, that's probably for 4 will be 3 over 25 plus probability for 5, that's 1 over 25. And that's the same thing they did here. Now they kind of draw this the data, they show it in another way. I have another representation for it now. This is how they did it. Instead of having this frequency here, they calculated for relative frequency. And how do you calculate for relative frequency? I've explained in the previous video. So just have this, for example, this 3, right? If you want to calculate relative frequency of this 3, have 3 over 25 times 100. That's the same thing they did here. See the first one, that will give you 12%. Understand? So that 3 over times 3 over 25 times 100, that will give you 12. The same thing goes to the next one, 5 over 25 times 100. That's the same thing. You understand? So now I'm not here to explain that. You should know relative frequency distribution. So they kind of plot it like that. So for the second one, this one it is 20. That's 5 divided by 25 times 100. 25 divided by 100, that's 4 times that's 20. So that's 20. So this is the distribution. By the time you do that for everything, 3 over 25 will like pick them one by one, divided by the total number, which is 25 times 100, get this data. So now, I don't even know why they did this, but quite easy for me. It's easy for me just to add this to over 25. Look at it. So look at what they did. Now say, as for the event x is more than 3, it is the same as the event x equals to 4 or x equals to 5, because x equals to 4 and x equals to 5 are mutually exclusive events. Okay, when they said they are mutually exclusive, don't forget the condition of mutually exclusive. That's just the probability of first and the second one, and they are not talking about the intercept at all. So we can use the rule of probability from section 4.4. You check back, you see the rule. Or can I still have it here? Yeah, this is for mutually exclusive. So P, probability of E plus probability of F. So that's the same thing. So and that's why we have probability of 4, which is 3 over 25. Like I showed you here. It's probability of 4. And this is probability for 5, which is 1 over 25. 1 over 25. If you add them together, you have this 0.16, and that's the answer to the second question. Now, the last question, that x is less than the mean of the distribution. For us to know that, we need to calculate the mean first. And how do you calculate the mean? I've told you, sum over the total number. Now, we'll calculate the mean of this distribution. So you multiply this 0 times 3 plus 1 times 5 plus 2 times 7 plus 3 times 6 plus 4 times 3 plus 5 times 1 all over 25, because that's the total number. Now, that's what they did here. They multiply it through and they got this 54 over 25 equals to 2.16. So this is the mean. Now the other said that you should look for the probability that is for values that are less than the mean. The mean is 2.16, right? Let's go back to the table. If you look at this, which one is lesser than 2.16? If you look at it, 2.16 is more than 2, right? Which is the mean. It's more than 1 and 0. So these are, you're going to calculate the probability for these three. Just these three. The first one is 7 over 20. This for 2 is 7 over 25 plus 5 over 25 plus 3 over 25. But for me, I told you straightforward. If I'm supposed to solve this question myself, if you do it that way and add it up, you're going to get your answer. But that for me that will waste time. So let me just add. For me, I'll just add 7 plus 5 plus 3, and that will be 15, right? Over 25. So that will be the answer for me. And you say, so probability that x 2.16 is more than x is probability of 0, probability of 1, probability of 2, which is probability of 0 is 3 over 25, like I showed you here. Probability of 1 is 5 over 25, and probability of 1 is 7. Probability of 2 is 7 over 25. So when you add them together, you have 15 over 25. Because that got 0.6, so that's the answer. Let's move on. Now this is the table for the they kind of compare. This relative distribution, probability, right? They change it. You can do a probability table too for your data. Instead of representing it this way, you can use, since we all know that probability of this first one is 3/25, right? And that's going to be 0.12. Probability of this one is going to be 5/25. And that's what they did here. So they just 3/25, 5/25, and that's how they got this decimal. 3/25 is 0.1212. 5/25, that's going to give you 0.20, and so on like that. And for the other ones too, 7/25, 6/25, 3/25, 1/25. So that's what they did here. And so there's no problem at all. Just even to calculate the mean, you can even use this data to do that. So you just multiply it by probability, the same as this. Since like when we calculated the mean the other time, so this is the same thing as 3/25 plus 5/25, 7/25. So you can input the probability inside each variable. This is the mean 0 times 3. So instead of having 3, you can have 3/25, 5/25, 7/25, 6/25, 3/25, 1/25. So that's what it does. So and that shows that the probability of 0, probability of 1, probability of 2, probability of 3, probability of 4, and probability of 5. So that's that. Now this is another question, and this question is we've done it before too, and I would like to repeat your memory. Let Y represent the outcome of the experiment in example 4.45 of rolling a weighted 6-sided die. Now in that example we gave an instance. Look at it. Let me check back to show you 4.45. This example. Suppose that there is 6-sided die that is weighted in such a way that each time the die is rolled, the probability of rolling any of the number from 1 to 5 are all equal. The probability of rolling 6 is twice the probability of rolling 1. So it means that it's not equally distributed. There's only one number that is equal. 6 is having a double. It's having a double chance. So when you calculated it here, you find out that the probability of this last one is going to be 2. And every other one will be 1. So P, this is going to be probability. This is going to have 2 probability. So let's go with that mindset. Let's go back to the question. Now, what they did here is just try to show you the representation. So we have die 1, die 2, die 3, die 4, die 5, die 6. Now, every probability of dying 1 is going to be 1/7. Probability of dying 2 will be 1/7. 3 will be 1/7. 4 will be 1/7. 5 will be 1/7. Why? Because we already told you in the question that from 1 to 5 we have the equal chances, which is 1. Now for probability of 6 has double chance. So that's why we're going to have 2/7. So it has 2 chance of being picked. So that's what we have. So you can even actually represent on the histogram like this. So if you plot it 1/7 like that, 1/7, plot them like that. So it's only this that has 2/7. So the last one. So that's that. So the mean or the expected value of y can also be computed as this. Probability of 1 plus probability of 2p 3 3, like the mean we're talking about. No, I calculated the mean for you here. This probability. You multiply this variable by the probability. So that's the same thing they did there. So 1 times 1/7, 2 times 1/7, 3 times 3. That's what they did here too. So probability 1, so that will be probability 1, probability 2 times probability 2, 3 times probability 3, 4 times probability 4, 5 times probability 5, 6 times probability 6. That's what they did here. So multiplying this with this, multiplying this with this, 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 and this with this. So the same thing they did here. So it's not as difficult as you think it is. So and when they did all of that, they end up having 3.86 as their mean. So that's another way of calculating your mean. If you are supposed to calculate the mean of the variable of the data and you know the probability, you can actually calculate it. So that is what this is all about. Now, this one is going to be what I'm going to be talking about fully, normal distribution, which is quite technical and complex. So this is what I'm going to talk about in the next video. Thank you.